The impact of global climate change on the coastal environment is of serious concern to India. The coastline of India and its many islands stretches over 7,500 kilometers. These coastal regions are not only home to some 17 crore people, but innumerable flora and fauna and unique oceanic ecosystems and biodiversity hotspots. But India's coastline is now highly vulnerable as a result of climate change and sea level rise. It's estimated that we have lost some 235 square kilometers to erosion in the last few decades. In this episode of Science for a Self-Reliant India, we bring you two unique initiatives by the Department of Environment of the Tamil Nadu government and the Department of Ocean Engineering at the Indian Institute of Technology, Madras, who are leveraging science and technology to protect India's coastline and islands. The first of these is along the coastline north of Chennai, where considerable land has been lost to the sea.
North Chennai, that is north of Chennai Harbour, we have evidences showing that we lost something like even up to about 300 to 400 meters of land into the sea. We have lost a temple which has gone into the sea. 50% of the highway is also lost. So now you go and see, now the beach has widened and at least we would say about 20 meters of beach have been formed. Whatever lost is formed.
We also see how our scientific institutions are employing artificial reef modules near the sinking Van Island in the Gulf of Mannar to reduce the effect of currents and waves in an effort to protect the landmass and also provide protection to the fragile coral reefs. The importance of understanding climate change and working to mitigate its effects quickly and efficiently go hand in hand with the vision of an Atmanirbhar Bharat. So let's begin our journey. India has a large coastline that runs across 9 states and 4 union territories. The boundary of a coast where land meets water is called the coastline. Coastal changes can take hundreds of years and are a direct result of the constant movement of waves breaking on the shore. The way coasts are formed depends on the topography and the composition of the material in the land and water. The harder the material in the land, the harder it is to erode. Coastlines of granite or hard rock last much longer. It's the softer material like sandy beaches or brittle coastlines that face the brunt of the constant action of ocean waves. But in geological terms, coastlines are dynamic and change over time. But now, scientists have established that climate change and rising sea levels are causing faster erosion of coastlines. For example, scientists estimate that India alone lost 235 square kilometers of land to coastal erosion between 1990 and 2016. Scientists also estimate that sea levels along the Indian coast have risen by 8.5 centimeters in the last few decades. The length of the coastline of India, including the coastlines of Andaman and Nicobar Islands in the Bay of Bengal and Lakshadweep Islands in the Arabian Sea, is over 7,500 kilometers. This coastline is home to approximately 17 crore people. Out of India's 7,561 kilometer coastline, 960 kilometers of it lies in the state of Tamil Nadu. The coastline of Tamil Nadu is naturally of considerable economic and geographical significance. With 2 major ports, one at Chennai and the other at Tuticorin, with several minor ports and fishing villages and harbours at different places, the coast is of immense socio and economic importance, providing lakhs of people with livelihoods. Construction of planned ports, harbours and industries over the decades has accelerated the erosion and also been responsible for degrading the environment along the coastline. The reduced rainfall due to changes in the monsoon pattern over the years has in turn lessened the sediment flow into the oceans. This reduction in the sediment flow has led to considerable erosion along the 15-kilometer stretch of North Chennai coast in Tamil Nadu from Ennore towards its south up to Royapuram. The entire eastern coast of India, from the state of West Bengal going down to Odisha, Andhra to Tamil Nadu, is also vulnerable to cyclonic activity. There have been more than 32 disastrous cyclones since 1900. Annually, around 3 cyclones affect the Tamil Nadu coastline each year. The tidal waves, heavy rainfall and winds that accompany the cyclones intensify coastal erosion.
You see that we have a coastline of about 7,500 kilometers, and we have varieties of problems, and these problems are either due to nature or due to man-made. Both can be possible, and some of the stretches are well below the very close to the mean sea level, so because of which when you have storm surge or anything like that, so you have inundation so high, and that creates a precarious situation which can be more vulnerable and more dangerous in case because of this climate change which we have been talking is a global crisis. So we need to take care of this.
The vulnerability of people and infrastructure on the coastlines was perhaps most evident on the 26th of December 2004, when a mega earthquake of 9.1 magnitude ripped through an undersea fault in the Indian Ocean close to the coast of Sumatra, Indonesia. It propelled a series of gigantic waves or tsunamis towards shores across the Indian Ocean, killing close to 2.5 lakh people. These waves also struck the southeastern coast of India, killing over 8,000 people. The challenges of natural disasters like the tsunami, as well as the constant erosion of coastlines, has impressed upon experts and government bodies to find ways to protect the more vulnerable areas of our coastline. Towards this end, the government of Tamil Nadu has been working to mitigate beach and coastline erosion along with the Ocean Engineering Department of the Indian Institute of Technology, Madras, and the National Centre for Coastal Research under the Ministry of Earth Sciences, Government of India, to work on coastal protection programs, especially in North Chennai coast. In the coastal environment, waves, tides, currents and winds are the important parameters which need to be considered for any planning and development. The effect of these environmental parameters varies over space and time. The knowledge of these parameters is essential in designing and planning of shore protection structures. For this, scientists at IIT Madras conducted various studies at the North Chennai coastal area involving the collection of bathymetry of the area, the data on waves like intensity, tides, current and winds. After analyzing the data, suitable remedial measures like construction of seawalls, groins and breakwaters were examined. Out of these, a combination of seawalls and groins was recommended by IIT Madras as the best remedial measures in controlling the erosion.
We are looking at all the kind of existing methods of coastal protection, and we are keeping in phase with all the developments around the globe. And as far as the know-how is concerned, the entire know-how is from our own institute. It is in-house and nothing is from outside. Some of the even measurement equipments are also made by us, and then the analysis, the design, conceptual design as well as, and we consider almost all the methods that are available for coastal protection.
A groin is a shore protection structure built perpendicular to the shoreline of the coast, over the beach and into the shore face to reduce longshore drift and trap sediments. Longshore or littoral drift is the movement of materials like sediments along the shore by wave action. This happens when waves approach the beach at an angle. The swash or the waves moving up the beach carries material up and along the beach. The backwash of the waves moving back down the beach carries material at right angles. This is the result of gravity. This process slowly moves material along the beach and provides a link between erosion and deposition. The intensity of the waves and the erosion of the coastlines also depends on many natural factors like storms, flooding, seismic activity, human activity, and now increasing effects of climate change. So it becomes imperative to protect the more vulnerable beaches and coastlines. For this, groin fields have been found to be very effective. Groin fields are a series of groins acting together to protect a beach. Rock is often used as construction material. Rock groins are generally preferred as they are more durable and absorb more wave energy due to their permeable nature.
We have widely used the groin field, and some of the locations we have used what is called as the seawall, and some of the locations, most of the locations we have used groin field. And the groin field are very, very effective in locations where the sand is moving along the coast. I will not go into basic physics, etc. But the general phenomena is at locations where the sand is moving along the coast, groins are found to be very effective, whether it is west coast or the east coast of India. And some of these groins have the pockets in between these groins serve as a small landing facility for fishermen, so thereby enhancing their livelihood, and they can easily land their boats, and also it forms as a shelter for them, and they are very happy.
Groins are typically built to stabilize a number of natural or man-made beaches against erosion, mainly due to net loss of beach material. The influence of a groin is accretion or build-up of the beach material on the updrift side and erosion on the downdrift side. Another way of using groins is to build a series of small groins or groin fields at short intervals along the affected coast. This will tend to stabilize the entire coast by keeping the sand trapped between them. Most of the beaches at the North Chennai coast have been protected after the implementation of the scientific technique with a combination of seawalls and groins. The 15-kilometer stretch is now strengthened by a groin field which has resulted in additional beach width. This scientific intervention by the collaboration of the state government and the scientists of IIT Madras does not only protect the beach from getting eroded completely, but will also provide safety to the population that lives in nearby villages and is dependent on the sea for their livelihood.
Chennai, that is north of Chennai Harbour, we have evidences showing that we lost something like even up to about 300 to 400 meters of land into the sea. We have lost a temple which has gone into the sea. 50% of the highway is also lost. So now you go and see, now the beach has widened, and at least we would say about 20 meters of beach have been formed. Whatever lost is formed. So it is a gradual process, but it will take care.
Apart from the coastline of India's mainland, the country's islands are even more vulnerable to climate change and the effects of erosion. Here again, our scientists and engineers are working to find innovative solutions to complex challenges of submergence of smaller islands. One such event of a shrinking island was noticed along the coastline of Tamil Nadu, some 600 kilometers from Chennai in the Gulf of Mannar, which is one of the planet's richest marine biodiversity hotspots, with 23% of India's marine life, including 2,200 fish species and over 100 species of crabs, and even the majestic humpback whales. In the Gulf of Mannar, one of the 21 islands named One Island and part of the Biodiversity Park was on the verge of submergence in the sea. Indiscriminate mining of coral and destructive fishing practices as well as climate change in the past decades, have been responsible for the submergence of at least 2 other islands.
The sensitive islands in the group of islands at the Gulf of Mannar, where this has been greatly degrading. One of the main reason is the coral degradation in this particular area. Apart from so many other factors, most of the things are anthropogenic factors. That's a human induced factors. So that has been degrading, and hence it is reflecting on the island degradation. So here we envisaged development of the corals to bring back the island to its natural position. This is what our primary idea on which we started working on the system development.
The area covered of Van Island was nearly 20.08 hectares or about 50 acres as measured from the survey of topo sheet in 1969. But the constant erosion over the decades reduced the island to 16 hectares in 1986, which then sharply declined by half to 8.05 hectares in 2009. In 2013, the island split in half as the middle land area sank. 2 years later, the separated northern part disappeared into the sea completely. In 2015, the island was reduced to just 2.33 hectares. The rapid sinking of the island worried the environmentalists and scientists who were closely monitoring the island's disappearance into the sea. The eroding island put the area's rich marine biodiversity under serious threat. Though the islands are uninhabited, the land, coastal reefs and marine life serve as a defense against the harsh weather in the sea, protecting the mainland. Corals use dissolved carbon from the seawater to build the skeleton, and hence they are capable of tackling climate change. Corals also serve as carbon sinks. Further, the coral reefs provide shelter to a rich diversity of flora and fauna. The Department of Environment of the Tamil Nadu government, along with IIT Madras and the Sugandhi Devadasan Marine Research Institute, or the SDMRI, started working together with a strategy to protect such islands on its coast by deploying artificial reef modules near the vulnerable islands. This was an ambitious plan, one that had never been tried in India, and if successful, had the potential to reverse large-scale erosion not only in this island but across other coastal parts and islands in India which faced habitat loss.
In the group of islands at the Gulf of Mannar, the southernmost island called Van Island has been degrading lot in particularly last 2 decades from nearly about more than 12 hectares to 1.2 hectares, and it has been noticed in early 2010 those stages, and this was very much alarming after 2000 the last 10 years it has been greatly alarming. So this has been noticed by the people, marine biologists working those area, those who are monitoring the coral and planting etc. It was brought to the knowledge of the government, Department of Environment, and they invited us to investigate what to do, what's the engineering or technology intervention that we can make it to bring back the nature.
For this, the Department of Ocean Engineering at the Indian Institute of Technology Madras conducted many experiments at their unique state-of-the-art lab facility. Scientists here conducted wave dynamics and bathymetry studies to finalize the design and locations for deploying perforated trapezoidal artificial reef modules. Artificial reef modules are triangular-shaped concrete structures with holes in them. The holes in the concrete structure were to achieve good water circulation. The holes are also required for marine growth. Each module is 2.5 meters in width, 2 meters in height, and weigh 1.8 tons. About 10,600 of these modules were painstakingly deployed at a distance of 250 meters from the island in a semicircular constellation, keeping a gap of 20 meters between each module. The trapezoidal structures help to dissipate the high wave energy and reduce the impact of the waves on the island. Deployment of artificial reefs parallel to the sinking island in the seaward side reduces the effect of currents and waves as well. It enhances fish habitats for higher fish production and protection of fish diversity. Natural corals get attached to these artificial reefs over time and start regeneration.
One aspect is how the island is protected now. Now, after the implementation of these structural elements there, waves got dissipated. And beautifully what happened is, the disintegration of the island had happened place by lowering the island, or the sediments are spread out to the entire area. Now, wave energy is less, island starts growing towards the north where it got disintegrated. That is one positive aspect. Now, after the first 2 years of growth, now it is getting an equilibrium position. Monsoon time slow, some part it is disintegrating, at some part it is integrating. I can proudly say the starting stage at the end of 2014, from today, island has grown up 100% more.
One island was on the verge of sinking completely when the project began in 2015. But after the successful deployment of the artificial reef modules, the water around the split has become shallower. Its depth has reduced from 2.5 meters in 2015 to 0.5 meters in 2020. The timely and scientific interventions by experts consisting of engineers and scientists have helped increase the land cover by 54%, and in doing so saved the island from being completely lost. Today, the landmass is gradually rejuvenating.
So, IIT Madras, we are not only developing some new system through research, we always try to see it's implementable, and also we go to the site level and work and make sure it is work. And that's one of the reasons Government of India or Government of State Government and many department, they approach us for a workable solution, and also they know that we are with them till its final implementation.
The experiment has been unique and path-breaking, as such a project was never tried before in India. Following the success in one, the government of Tamil Nadu has proposed to undertake restoration of 2 more islands. The close coordination between the Department of Ocean Engineering of the Indian Institute of Technology Madras with the state government of Tamil Nadu and other agencies to mitigate erosion on the 15-kilometer stretch of the Chennai coastline, and the measures to save one island in the Gulf of Munnar are live examples how important scientific and engineering solutions are when it comes to finding and implementing solutions for pressing environmental problems that we face. The success and learning from these projects also strengthens India's self-reliance and furthers the Atmanirbhar mission.